Greetings, and welcome back. It's so fantastic to be with you again on another great night of learning about inequalities, becoming individuals of character and intelligence. I just love spending time with you, and I hope you feel the same way, because that attitude will take you a long way when it comes to doing things. Even some things you may not like to do, but you know you have to do them. You just got to get them done. There are those things in life, they never go away. When you become an adult, there will still be things you have to do even when you don't want to. And learning how to do it with a positive attitude not only helps you get it done, not only helps you get it done faster, more importantly, helps you get it done correctly and right. Ladies and gentlemen, lesson 4.3, page 140, where we're continuing with inequalities. And tonight we're going to apply what we learned to solve inequalities using multiplication and division. And I know what you're thinking. And you're absolutely correct. To think that solving inequalities with multiplication and division are exactly the same as solving equations with multiplication and division. However, there is a caveat to that. We got to star it. We got to put an asterisk on it, because there's two different types of ways to solve using multiplication and division. The book calls them cases, so we're going to call them case 1 and case 2. So let's get started with case 1. Right from the top of page 140, you should have taken some notes. And those notes should have said that when you multiply or divide each side of an inequality by the same positive number, the inequality remains true. This is very important. Positive number. Case 1 is multiplying or dividing with positive numbers to solve the inequality. So our numeric example of that would be if I have something like 5 is less than 7, and I multiply both sides by 3, that's a positive 3. I would get 15 is less than 21, and that is a true statement. That is a very true statement. Using our algebraic way of showing this, if I have A is greater than or equal to B, and I multiply both sides by C, I would get A times C is greater than or equal to B times C. Absolutely. That's correct. Case 1, multiplying or dividing with a positive number. So let's talk about dividing. I showed the multiplying thing. How about 10 is greater than 5? If I divide both sides by positive 5, then I would get 2 is greater than 1. And of course, using division, A is greater than B. If I divide both sides by C, then A divided by C is greater than B divided by C. Multiplication and division with a positive number. So let's get right into it. Solving an inequality using multiplication using case 1, meaning everything's going to be positive. So here I have in number 1, n divided by 3 is greater than or equal to 1. So how am I going to isolate n? Well, I'm going to do the inverse. And the opposite of dividing by a positive 3 is to multiply by a positive 3. And of course, my property of inequality says I can multiply both sides by that positive 3, and the inequality will stay true. So n is greater than or equal to 3. Graphing it, 3 is my target number, 4 is greater, 2 is less. I have a greater than or equal sign, so my target number is included using a closed circle. My variable is on the left, so I can follow my inequality symbol to graph the remaining solutions, all of the solutions that make that inequality true. It goes to the right. Our next example. 2. We have negative 0.5 or negative 5/10 less than m divided by 10. So we want to, 1, isolate m. How do we do that? Inverse operations, which means we're going to multiply that side by 10. And we're going to get m because these two cancel out. Our inequality is going to stay true because we're going to multiply both sides by that positive 10. That's case 1, positive 10. So 10 times a negative 0.5 is negative 5. So negative 5 is less than m. I don't like my inequality on the right. I'm going to rewrite it as m is greater than negative 5. So now that I have my variable on the left, my target number is negative 5. One that is greater is negative 4. One that's less is negative 6. I have an open circle because my target number is not included in the solution. And since my variable's on the left, it's the first number listed in my inequality, I can again graph to the right showing all the solutions in this or for this inequality. Let's go to division. Solving inequality using division. And then, of course, we're going to graph the solution. We have 4b is less than or equal to 16. The inverse operation of multiplying by 4 is to divide by that positive 4. So that leaves me b. I know my inequality is going to remain true because case 1 says anytime I use my property of inequality of dividing by the same positive number on both sides, that the inequality will remain true. And 16 divided by 4 is 4. I have my target number 4. One greater is 5, one less is 3. My variable is on the left. So let's talk about, my target number 4 is going to have a closed circle. It's going to be included because it's less than or equal to. It's got the line under it. And again, my variable's on the left, so I can follow the inequality and graph my arrow showing all possible solutions to that inequality by graphing to the left. And our last, no. Not our last example of the night. For some reason, I've been saying last example of the night when it's not. Our last example of this video. Number 4, negative 15 greater than or equal to 2.5w. So, of course, our inverse operation is to divide by 2.5. That is a positive 2.5. That leaves us with w. And our inequality is going to remain true because we're going to divide both sides by that positive 2.5. And negative 15 divided by 2.5 is negative 6. And I don't like my inequality having the variable on the right, so I'm going to rewrite it. W is less than or equal to negative 6. Now I have my target number, negative 6. One that's greater is negative 5. One that's less is negative 4. And of course, we're going to use a closed circle because our inequality is, our solution is included in this inequality with the line being underneath. And with the variable on the left, I can follow my graph by graphing to the left because that will show all the possible solutions. And again, with any of these, if you're ever in doubt, we always conduct a test. Ladies and gentlemen, let's do our first quick write of the evening where you have 2 inequalities to solve. One of them requires you to use multiplication. One requires you to use division. Make sure you draw your own graph with your 3 numbers that are needed and solve those for us to discuss in class tomorrow when we revisit our notes. And as always, it is good to take a little short break between now and the next video so you can refresh your brain and come back ready for case 2, because case 2 is a little bit different than what we've talked about before. We'll see you in a few minutes.